thing on the page. Okay, so I'm talking about this one. Can you see?
Yes.
Yeah,
Boleh
okay.
betul.
Yeah, okay. This is the last page of your assignment instruction rubric. Okay, so the previous page will be how we will give marks for your works in the assignment one. Okay, so basically what I'm talking about is the first column here. Okay, I'm just talking about the format of your poster. So it's either you use the PowerPoint or you use the Canva or you wish to use the Excel. I don't mind, okay, as long as the submission will be in one page of PDF form. Okay, so what should be written in the assignment, everything is being explained in the first column here. How do you submit and everything through Google Form? Later I will share with you the Google Form that you will need to use for your submission. Now, what will be the things included in your assignment one? That will be in the second column. Okay, so poster sections means that the first one, background, 80 to 120 words, okay, which include the background of your data, what you are trying to do, and what you are trying to know from the data, the purpose. Okay, question one, you want to answer by using the data that you choose, and why do you think the findings are important or rational to your investigation? Okay, so these are among the things that you need to write in the background. After background will be your objective. Okay, it should contain four specific and measurable objective. That would be, okay, these are among the example of the wordings, okay, to identify what, to investigate what, to compare what, to analyze what. So you can copy these four sentences or words to be your four objective, but the dot part, you need to identify what will be the things that you need to, for example, the first one, to identify what, to investigate what. Okay, so that will be goes back to your data that you choose. Okay, and for data and methods, 100 and to 100 to 120 words. Okay, the things that you should include in your poster would be state the possible target population, the sample, and the sample size. Now, we have learned about population, what is sample size in the previous class. So means that by using the data that you choose, identify what would be your population. So as I mentioned before, the population should reflect the the defined period of time, or the defined time period that you choose for your population, or the defined time frame, or the defined context of your population. Last time we are talking about skewers, right? Skewers produced by Wallaby Company. So if I'm talking about population for 1 month, then you are talking about the whole production of 1 month. If you're talking about the production population of 1 day, then you are talking about the production of 1 day of skewers. Okay, so that's how we define that particular population sample. And of course, the sample size would be very easy based on the data that you have, how many observation that you have in your data. Describe the qualitative and quantitative variable in your study. So with regards to your data that you choose, so there will be differences in the data set. Okay, some of you may have four variables only, some of you may have maybe up to 10 variables in your data set. So it depends which data set that you choose. Okay, briefly explain the descriptive statistic method, graphical and numerical presentation applied in this assignment to achieve each objective. Means that you know that you want to achieve these four objective. Okay, in order to figure out the finding of these four objective, so you have to choose what kind of graphical and numerical presentation that would be suitable for you to choose in order to come up with the objective of your analysis. Okay, and then finally you have your result and discussions. Okay, I don't want to talk about this too much. Later, once you have got your data, when you see and you start doing the assignment, then only I think the part 4 would be significant for you to discuss. Then you can come and see me and discuss about your assignment. And finally, the conclusion. Okay. So number 4 and number 5, I'm not going to talk about too much about that. So later, once you have everyone has finished choosing your data set for your assignment 1, I will email you. I will email every representative from each group the data set that you have chosen. Okay. Any questions so far for this particular assignment instruction class? Any question, class?
Yes, doctor, sorry.
Yeah.
Can you please give us an example of the assignment so we can refer to?
Last time I have shown you in the first class, right? I have shown you. In fact, you in your e-learning,
Yes.
you go to your e-learning. You go for the instruction. So there will be a link, for example, link for various example of this assignment, this poster. So you can see from that particular poster that available in the e-learning, and see how all the poster is being presented. Okay.
Okay, doctor, thank you.
Okay. So class, if you have I believe in order for you to come up with your poster, you will have to come and see me, and we should have some discussion, because definitely you are going to once you have got your data, you are going to ask yourself too many questions. How does this should be done? Okay. How does this data should be analyzed, and so on and so forth. So I believe that one will require you to come and see me, and to have some discussion about the data that you have, or the data that you have chosen. Okay. So if you don't have any more questions, I would like to go straight to the our chapter. Okay. So last time you have I'm trying to reduce the view, okay, but never mind. Okay, last time we have discussed until qualitative data presentation. So qualitative data presentation, we have seen bar chart, we have seen pie chart, and then I think that's all. But you can have more than what we have discussed, actually, based on the uh, different option of charts that you may have in the Excel. Okay, so just to give you some idea, so we have discussed about the bar chart. In fact, we have discussed about the histogram, and then we have seen how we can come up with our pie chart from our qualitative data. Now, if you go to your textbook on page yep, on page 14, you can see this particular example in your textbooks. Okay, on page 14. Okay. Okay, you can see these particular charts, these pie charts. Okay, and then if you look at your page 14 as well, okay, um, you can see different types of bar charts. Okay, for example, the first one is bar chart, which shows you the categorical of your data, of your qualitative data, that will be presented in the x-axis. Okay, it depends on what type of charts that you choose to be presented. Is If you look to your Excel, the categorical can be placed in the x-axis or in the y-axis. Okay, it depends on which option that you choose. Now, a part of bar charts that you may have, you can also have stack bar chart. Okay, sometimes you may have certain data whereby you wish to see, okay, uh, with regard to several particular what we call qualitative or categorical variable. For instance, in this case, I wish to see the performance from machine 1 and machine 2, whereby we know that under machine 1 and machine 2, it will involve different groups. Okay, so this one reflects the groups. Okay, so this one reflect uh, the qualitative or the categorical value, or the categorical variable. Okay, so it depends what kind of information that you wish to uncover once you have selected your chart types. Okay, you can also have the one that we call as group bar chart. Okay, for example, if you wish to see the performance between week 1, week 2, and week 3, whereby for each week it will involve two groups. Okay, so you can easily see for each week which of the group perform much better compared to the other one. Okay, so in this particular chart, you may also use this group bar chart if you have more than two groups. Okay, goes back again to your intention. What are the information that you wish to uncover from the particular graph that you generate? Okay, so the pie chart will explain again. Now, let us move to graphical for quantitative data. Is it still qualitative? No, this one is for quantitative. Okay, for quantitative. We can have histogram, line chart, frequency polygon, ogive, stem and leaf, and box plot. Most of the time, the one that we usually use will be histogram, stem and leaf, not stem and leaf plot, okay, but box plot. Okay, the this one depends. Okay, because when I say histogram and box plot, it will be frequently used because these two charts are beneficial or very important in order to help us out in doing a numerical summary presentation. Okay, later we will see. But let us look at the quantitative data for the graphical part. Okay. Now, last time I have shown you how we can come up with this particular histogram, right? By using Excel. Before we can have our histogram, definitely we will have to come up with our frequency table. So last time we have done that using Excel in order to come up with this particular frequency. And once we have got our frequency table, we can transform them into what we call histogram. Okay, so what are the graphical form for quantitative data? Okay, so other than histogram, you can also use bar chart. You can also use pie chart. This somewhat similar to qualitative. Okay, you can also use line chart. Okay, or frequency polygon. What types of line chart? If you look at your textbook, page 16. Okay, section solution, you can see example 1.6. Okay, you can have your line chart. Okay, for that particular example. For ogive and frequency polygon, okay, so this one is frequency polygon. Okay, now how do I get this frequency polygon? It's actually coming from this frequency distribution, okay, or histogram. Okay, how? See class, for first bin, we call this as our first bin. This is bin 1, this is bin 2, this is bin 3, and this is bin 4. So this one, all the bins reflect this bin number 1, number 2, number 3, number 4. Now, how do I get my frequency polygon? It's actually from the histogram, but I don't want this particular all the box shown in my frequency polygon. Instead, I am using the midpoint of that particular bin. Now I'm talking about for the first bin, 2 is the point. For the second bin is 7. Third bin is I think 9, and then we come back to bin number 4, 2. Okay, so that's how we come up with this particular line. So then we connect them from point to point. So that's why we that's how we got the frequency polygon. Okay, now apart from that, we can also have our ogive. Now, how do I get my ogive? Is actually from frequency polygon. Okay, how? If you go back to your can you see class? Here I know it is 2, here is 7, here is 9, here is 2. So we add the frequency from the first bin to the second bin, so on and so forth. So the first bin remain 2, the second bin will be 2 plus 7, you will get 9, and then the third bin will be 2 plus 7 plus 9, you will get uh, 9, 7 is 16 plus 2, 18. So here is 18. Okay. And last one would be the summation for all the frequency. That will be 20. Clear, class? Just to give you the idea first, okay? Later we will see how we can use our Excel to generate all this, at least part of the charts. Any questions so far?
No, madam.
Okay, thank you. So let us move to the last two charts that we can use for our quantitative data. The second one is stem and leaf. Okay, stem and leaf, there will be a specific info, what we call example later. We will see how we can come up with this particular stem and leaf charts. Okay, so and the last one, which is the most important charts that we will use in statistic, will be the box plot. The box plot, or we can call it as 5 numbers summary. Why we call it 5 number summary? Because we have the first one, information is minimum. The second one is the quartile. The third is the interquartile range. Number 4 is the quartile, third quartile. And number 5 is the maximum value. So that's why we call it as 5 number summary, or sometimes we call it as box plot. Okay, so this box plot will show you how does your data looks like. Most of the time we will use this box plot, okay, to figure out our distribution, okay, data distribution, to see data distribution. Okay, last time I said about the histogram. We can use histogram to see our distribution of data. See, this is how our data distributed. If I use my green pen, okay, so this is how my data looks like. So the green one is what we call distribution of our data. Statistic will talk a lot about distribution. How does your distribution of the data? Is it skewed? Is it symmetric? Is it skewed to the right, or is it skewed to the left? So on and so forth. So statistic is about dealing with data. Data, most of the time, we will want to see what is the distribution of your data. Once you know what is the distribution of your data, you know which method that need to be used to analyze your data. Okay, so that will be basically among the charts that can be used to represent our quantitative data. Class, so far, do you have any questions? Okay. So if you don't have any questions, okay, let us look at the example on page this one is on page 17. Okay. Page 17, example 1.8. Okay. Page 17. Okay. Now you have your data here. Now, how can I plot my stem and leaf? Okay, so please ignore the plot that is I cross here because the plot is a bit mistaken. Okay, so what do we have to plot our stem and leaf? Okay, stem means that this is the part where the stem is located, and once you have your stem, the next to your stem is your leaf. Macam pokok kita ada pokok. Kalau kita ada pokok, okay. So this one, it's what we call stem. This one is what we call yang sini ni is what we call our leaf. Okay. Now, how do we plot our stem and leaf? Okay. If you have three, for example, in our case now we have two. The most is with two numbers, means that I have first, second. Okay, and I have first only here. Actually, it's two. Okay, you can imagine as 0, 2. This one is the first number, and this one is the second number. Okay, so maximum number is 2 for each value. Now, sometimes you may have 3. For example, if you have 3, then you will have different stem here. Now, let us look easily for this particular example. You have this data. Okay, how do I plot my stem and leaf? Okay, so what you should do, you will have your stem part and you have your leaf. Now, the stem would be the value, the inner value. Okay, so this is the stem and this one will be the leaf. Okay, so that's how we put them together. So here, what is the stem? The stem is 0. Okay, and the leaf is 2. Now, let us put together. How can we put them together? So, identify from your number here. Okay, identify from your number how many values that involve in your data set. If you can see, the lowest is 2. The maximum is what? The maximum is 21, right? So, how do you move? You have 0, 2, you have, yep, 23, sorry. Yep. So you have 23, the maximum value, and then the lowest value is 0, 2. So means that the middle would be the one that will have 1x. Okay, so you will have 3 sections for the stem. That will be 0, 1, and 2. Then how I should complete my leaf depends on the value that you have. Okay, so let's say we begin with our smallest value with one number only. So let's say I use my purple pen. So I have 2, 4, 9, 3, 5, 9, 3, 3, 4, 8. Okay, so we begin with the smallest value. So the smallest value is 0, 2. Then you put 2 here. And then we have 3, 3. And then 3, 3. Number 4, you got 2, 4. And then 8. And then 9. You got 2, 9. So 9, 9. And then you got, oh, you got 3, 3 here. Okay. Complete. Okay. Now we start with the number with 1. Okay, so we have 18, 14, 13, 11, 13, 16, 10, 19, 16, 10, 15, 20, 12. So we begin with the smallest value. We have 10. How many 10? 2 10. So 0, 0. Lurus, follow the value above. And then we have second smallest is 11. We have 1 11 only. Then we have, oh, we forgot 5 here, right? No one tell me. We have 5 here. So we have 5 here. Okay. So then you have 0, 0, 1, 11. Then you have 12. You got 2. And then 13. 13, you got 2, 13. So 3, 3. And then 14, 4. And then 15, 5. And then 16. And then 19. 18. And then 19. Okay. And the last one is for the 20s. Okay. So 20 value. So that would be 21, 23. So 21, 23. So this is how you get your stem and leaf. Stem and leaf can also be used to identify the distribution of your data. So if I plot the distribution, more or less the distribution would look like this. So you have to twist. Okay, so you have to put um, stem here, leaf here. So you will see it will be somewhat here. Okay, so you have 0, 1, 2. So you have 2, 3, blah, blah, blah until 9. And then you have 0, 0 until 9. And then you have 1, 3. So you can use stem and leaf also to identify the distribution of your data. Okay. So most of the time, if you look at your page, okay, if you refer to page 19, okay, on page 19, refer to table 1.14. Okay, so you can see on page 1.14, if you can see here, okay, uh, the summary of graphical presentation for quantitative data. So you can see how does the histogram tells you about the data. Okay, so how does the line chart or time plot tells you about the data? Okay, what is the advantage of stem and leaf? So everything is being explained in page 19, table 1.14. So please understand the particular summary of graphical for quantitative data. So it might be asked in your question, I don't know. So please make sure that you understand. Okay, what is the purpose of doing histogram? What is the purpose of doing OGIF? What is the purpose of doing box plot and so on and so forth. Okay. Any questions of our class?
No, madam.
Any question? No. Okay. Now we have done our graphical part. Okay. Now we will move to our descriptive using numerical presentation. So under numerical presentation, we have 3. That will be measure of central tendency, measure of dispersion, and measure of position. So sometimes measure of central tendency, we call it as MCT. Okay, measure of dispersion is either MD or MOD. Okay, measure of position, MOP or MP. Okay, so why we need to know about these 3 numerical measure for our data? Apart from graphical, let us go back to our graphical. Okay, so if you look at these particular charts, okay, sometimes you cannot uncover more information from the charts that you generate. Okay, so sometimes the chart won't be sufficient for you to explain the whole thing about your data. Okay, so that's why apart from graphical presentation, we must use our numerical presentation, which include these three. Okay, which include these three. So let us look one by one. Very quick on these three. Then later, hopefully we have time, we can look at how we can use our Excel to come up with the analysis easily using Excel for all this MCT, dispersion, and position. Okay, so now let us move uh, to the method that we can use under each of these particular measures. Okay, so if you are talking about measure of central tendency, definitely you are going to talk about the mean, the median, and the mode. Okay, this one refers to the data. Okay, we are going to identify what will be the mean, what will be the median, what will be the mode from your data. What about measure of dispersion? We will have range, variance, and standard deviation. And the measure for the position, we will have z-score, percentile, quartile, and outliers. Let us look at the first one. Measure of central tendency. Okay, so what is measure of central tendency? Okay, we call it as mean. Mean of a sample is the sum of the sample data divided by the total number of sample. Okay, so class, remember last time we are talking about ungrouped data and group data. So in this slide, I only include for group data. Since we are talking about Excel, we are going to use Excel. So our concentration will be based on the ungrouped data. But if you wish to know more about your group data, you can refer to your textbook. Okay, so the textbook clearly discuss in particular how we can use the group data in order to find for each of the measure of central tendency. Now, very easy. Mean, if you have n data set, means that let's say you have 10 data set, you add all the 10 values, then you divide by the number of sample. So this one is what we call number of sample. Now class, if you look at this particular X bar, what is this referring to? Is it statistic or parameter class? Statistic or parameter class?
Statistic.
Why statistic? Why statistic? Why statistic?
Involve all data.
No. If you are talking about all data, it will be parameter. All data. And your n would be capital N. See, you are using your small n. So small n reflect your sample. So we know that statistic reflect data from sample. So if you see, our X bar is referring to statistic. Okay. Now, how does the formula looks like? You add all the X. This one is summation. Summation means that you add the first value, second value until the nth value. You add all them, you divide by the number of n. So if you're talking about your n 10, so you have n equal to 10 here. So you have x1 until x10. Okay, simple. Okay, the next one will be the median. Now, what is the difference between the mean and the median? Now, if you are talking about this particular, let's say, imagine your data from the minimum value to the maximum value. So this one is minimum, this one is maximum. Okay, where does your X bar located? Most of your time, your X bar will be located in the middle. Okay, this one reflect the mean. Okay, so measure of central tendency, as the name shows here, we are talking about the central value of your data. So if you're talking about the mean, remember you are talking about the center value of your data, most probably located in the middle, but it depends. If your data, most of them are very large, then your X bar will move to your here. If your data contain too many big value, okay, but if your data, most of your data are very small, but some of them got maximum value, then it will move to this particular part. Okay, so here your X bar, if located here, means that your data contain too many small value. Okay, so that will be the difference how your X bar can shift to the left or to the right based on the values inside your data set. Now, what about the median? Median also, we are talking about the middle part, middle value. Okay, so the median will always can also be in the midpoint. Okay, but how can we find the median value? So it will go back, if we are talking about the ungrouped data, so we are talking about the data, it could be even or odd. If n is odd, means that, for example, my data, okay, I have 2, 4, 6, 7, 7, 8. So how many data? 1, 2, 3, 4, 5, 6. I have n equal to 6. So this is what we call even. Okay, if I have additional, let's say I add one more, I got 10 here. So here I have n equal to 7. So this is what we call odd. So it depends on the value of your n. How many n do you have in your data set? If your n is even, okay, if your n is even, means that your middle value would be, okay, so what would be your middle value? Since the number has been ordered from the lowest to the highest, so let's say we are talking about this particular value, so the middle value will be what, class, for even? It's between here, right? So this will be the median value, right? So we have 1, 2, 3, 1, 2, 3. Okay, what about if your data is odd? If your data is odd, okay, we are talking about this particular value. So 1, 2, 3, 4. 1, 2, 3, 4. So this will be your middle value. This will be your median. So that's why, class, if your n is odd, okay, then the median is the middle value. So this one, if odd, the median is the middle value. So if n is equal to 7, median is equal to 7. Coincidentally, 7. But when my n is even, so it will be located in between 6 and 7. How I can get my median? So if my value is even, so my median would be, you add the two. You take the arithmetic means. So you take 6 plus 7 divide by 2. You get 6.5. So the median for the first data, even data, you get 6.5. If you got odd value, data value, you will get 7 for your median. As simple as that. Okay. If you have any question, just stop me. Otherwise, I'll just go ahead. Huh? Now, see, when we are talking about median, class, so what happened, class? Still, we are talking about middle value. Okay, numbers or data set that is being located in the center of your data. Now, let us look at mode. How can we call it as measure of central tendency? Whereby we are talking about the mode. What is mode? Okay, for ungrouped data, the value with the highest frequency in the data set. Okay, so what will be the highest frequency? So if you go back here, you will see how many the value repeated. Okay, so in this case, we have repeated value 7 twice. The rest got only 1, not more than 1. So in this case, we call it 7 as the mode. Okay, what if I have data, for example, class, I have data 3, 2, 3, 5, 7, 8, 10, 13. What is the mode for this particular data, class?
13.
Why 13?
Sebab dia nombor boleh besar.
No, wrong. See the definition, the value with the highest frequency. The highest frequency. All the value here only appeared once, right? Each value appeared only once, not more than once, right? So here we will say no mode. Okay, so the next question, can a data set has no mode or more than one mode? Yes. The answer would be both yes. If your data got no repetition, means that there is no mode. If your data got similar repetition, for example, I have 2, 3, 3, 5, 7, 8, 8, 10, 13. So the one that repeated is 3 and 8, both with similar frequency. How many frequency? Frequency is equal to 2. Also here, 2. So the mode will be 3 and 8. Okay? Clear? So class, mode, we call it as measure of central tendency. But sometimes it will not be located exactly in the middle. It depends on the distribution of your data. Means that how your data repeated, okay, in your data set. Okay, so if it is repeated in the smaller value, then it will be shift to the left. Okay, the same goes to if there are more values, bigger values with the highest frequency, then the mode will be located at the upper side. Okay. Now, for example, in this case, if I were to calculate in terms of the what we call the way we write, okay, so mean of the sample would be summation of all x divided by n. So here my n would be how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10. So summation of all x means that add lah. 2.9 plus 2.92 plus 2.96 plus blah 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 until 3.01. Then divide by 10. Okay. So what is the value here, class? Numerical data presentation. Okay, on page 23.
2.67.
Okay, 2 point. Is it 2.67?
26.7.
26.7. Hopefully it's correct. So I didn't calculate. Hopefully it's correct. Okay, so that will be how you can find your mean. Okay, so if you go back, because is the number arranged according to the smallest to the highest? 2.9, 92, 96, 96, 98, 98. Yes. So means that this is the minimum value. This one is the maximum value. So where is the 226 point? No. Is it 26.7? It's not divided yet by 10, right? So it will be 2.67, right? So 2.67, if I were to draw the line for this particular data, betul ke ni? 2.67. Can someone calculate? Is it correct?
Correct, madam. Betul.
2.67 is in fact much lower than the minimum value. Wow.
3 point.
3 point? Ada dengar suara tadi tu? 3 point apa? Ya Allah ni. Can someone please check? Is this correct?
2.67.
2.67.
Yes, madam.
Okay, 2.67. 2.9, 2.96, 96, 98, 98, 99, 99, 99, 3.01.
Tapi doktor dalam buku dia divide by 20.
Ada 20 ke? Dah ada 10.
2.97.
2.97.
That that will be make sense. Okay. Sekejap ya, saya jawab satu-satu. Okay. So 29.7, right?
Yes, madam.
Okay, divide by 10, you get 2.97. So if you are talking about 2.97 means that you are talking about here will be the location of your X bar. Okay, almost in the middle, but shift to the smaller value. Okay, so in the book, I guess so in the book, but divided by 20 is referring to the data set for external ring diameter for the night shift. So number 3 Roman is divided by 20 is reflecting the data at the beginning of our discussion that reflect the internal ring gear, external ring gear. Okay, so in this case, we divide by 10. Now, measure for central tendency for the median. What is the median? Okay. Remember class, data must be sort first. Sort means what? It's either you go for minimum until maximum. Make sure no mistake in terms of locating from lowest to highest value. The easiest one is from the minimum to maximum values. Just for in our case, everything has been arranged from the minimum to the maximum value. So now, how can we find the median? Median is the middle value. How? Let's see. How many data? We have 10, right? So 10 means that we are talking about even data. So it will be somewhere 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So in between, it will be here. So the median would be somewhere here, which is, if you're talking about the median, you can use X. Yeah. This the notation for median. So it will be 2.98 plus 2.98 divided by 2. So it will be what? 2.98. Right? So your median 2.98 here. Okay. Now for the mode, okay, let's see. The mode, as I mentioned just now, reflect the frequency. So how about this value? So we have 1, 2. 2.96, 2 frequency. 2.98, 2 frequency. 2.99, 3 frequency. The highest frequency is 3. So in this case, our mode is 2.99. Okay, so that's how we come out with the what we call value for the measure of central tendency. So let us look at the Excel part. Okay. Okay, for the Excel part, before I go to the mean, mode, and median, okay, last time I have discussed about this particular, I've discussed about how we can find the tabular or table of our frequency of our class boundary. And then from this table, we can generate our histogram. And then we have also used box plot in order to come up with our charts for this particular quantitative data. So this one I have already shown you last time, right, class? Am I, class? Are you all with me, class?
Yes, doctor.
Yes, madam.
Okay. Have I shown you how to generate box plot?
Not yet.
Not yet. Okay. Now, remember, box plot is for quantitative data. Histogram can for quantitative and qualitative. Okay. If for histogram of qualitative, that will be reflecting the categorical. But for box plot, okay, there will be some what we call continuous data or quantitative data suitable to be used using Excel, but somehow there will be data that will not be suitable using box plot. So please make sure the purpose of generating the box plot serve the reason why you want to discover the information from the data. But in this case, last time we are talking about the correction time. Remember, we are talking about advanced driver and a beginner driver, and then they will have to go through three different types of road: pave, gravel, dirts. And then the correction time is reflecting how many seconds each driver used to make correction in the steering. Okay, so that is the data that we are talking about. So in this case, class, we wish to plot the box plot for the correction time. So what do? Highlight your data and then go to insert. Okay, go to recommended charts and then go to all charts and then look for box plot. But in the Excel, it mentioned about box and whiskers. Okay, then click OK. Now you will have this particular charts. So since I would like to know what are the values, so I go to chart design and then go to data labels and just choose whichever format that you wish to have. In my case, I would like to have this. Okay, so if you think that the value is too small, go to click at the value. Click at the value, it will automatically go to each of the data label, and I would like to increase the font so that it will be easy for me to see. And because the color is not really helpful, so I go to chart design again and change the color so that I can see the value in the middle. So here class, we know then this is our maximum value. Drawing. I cannot. Okay, since I cannot use the pen, so here you can see 2 is the minimum value. 27 is the maximum value. So you can insert, maybe you can put text maybe. Okay, here is the minimum value. Okay, you can also add the maximum, and you are talking about the Q1, Q2, Q3. Later we will see. Okay, so this is how we can generate our charts. Now, How can we use this to identify our distribution? Last time we have seen from the data, we are referring to the same data class. Correction time here, we have correction time frequency table over here. So what happened? We would like to know what is the distribution of our data. So from the histogram, we can see this is the distribution of our data using histogram. And if I were to take this plot and put somewhat in this form, okay, so this is the minimum value here. This is the maximum value. See, the minimum is 2, the maximum is 27. So you can portray this particular so you can see this particular charts, okay, clearly. How does the distribution of this particular data looks like? Okay, what can you tell class? Why we call it box and whiskers instead of box plot and 5 number summary? Because we call this as whiskers. Misai kucing, whiskers, misai. Okay, now what is the difference between this whisker and this whisker class? What is the difference? Class? Let's say I'm talking about this A here. And then I have B here. What is the difference for the whiskers A and B, class? Can someone tell me? Class? Are you all with me? Hello? I'm talking about this. Class? What can you tell about whisker A and whisker B? Can someone please answer? Class? You all ni ada ke tak ada ni?
Ada madam, tapi tak tahu
Ah.
jawapan.
Simple. What can you tell about this whisker? Short or long only? A's whiskers is shorter than B whiskers, right? Am I correct?
Yes, doctor.
Yeah. So means that look at the histogram above. So means that you can see that the concentration of the data is more on the left side. Okay, see the frequency for the third bin is 7. For the second bin is 5. The first bin is 6. And whereas for the bin at the higher value only 3. That's why the whisker here is a bit longer than A. And in fact, the box inside is merely to the lower value because the concentration of the data is merely in this particular site. That's why we can use these two as our distribution. I hope I can draw, but my pen cannot work here. So I don't know why. So if I can use my pen to draw, okay. So you can see, look at my cursor. My distribution would be somewhat like this. Okay. The whiskers is longer at B, so means that we call it as skewed to the right, a bit skewed to the right. Okay, we call this as skewed to the right. a bit skewed to the right. To the right. Okay, because the whiskers is longer in this particular area. Okay, skewed to the right. Any question so far, class here? Now, before we go to the numerical, I would like to show you how we can use our dot plot. Okay, so if you go back to your Excel sheet, there is a what we call a website, but I have checked that the website is not really helpful. So how can I plot the correction time here into a box, a dot plot? We call this as dot plot. If you look at your recommended charts, okay, if you look at your recommended charts, okay, go to charts, recommended charts, all chart, you can see there is no option for dot plot. So how can I use the option that we have here to come up with our dot plot? So you have to do one extra work here. Okay, what is that? You have to count how many times this particular value appear in the data set. So in order to calculate how many it appear in your data set, so for example, see 13, you got 2. The first 13 here, the second 13 here. So that's why you got 2. And then 23, the first one here, the second one here. Okay, so you can see for number 8 here, you have 1 here, 2 here, 3 here. So how can I calculate? I use this particular what we call function. Okay, count if. Okay, just follow. But remember, class, you can see that the dollar sign only appear in the first. You kapit dengan dollar sign ni pada first. Yang second only first sahaja appear. Supaya dia kira the way we can calculate them. So if I were to do it again for you, how I can do that? Equal to count if. So look for count if, double click, and then you have the range. That will be the first observation, comma, observation, semicolon, and then comma, the same location of your data. But now since we want to calculate for the whole set of data, so you have to lock the location of the observation by putting the dollar sign. And for the first one, you got to put twice dollar sign, but for the second one, you only put $1 sign. Then click enter. Then what? Copy and then paste. Okay. Paste. Sorry, I forgot not to. It's not paste value. Okay. Copy and then paste. Okay. So once you paste, the Excel will calculate for you. Now, when you have that, okay, let me erase this. So you go and highlight the value here, both column, and go to insert, and then automatically you will use the scatter plot. See, you use the scatter plot and choose. You can either choose this one, or I think this one much better. Okay, so then click OK. So you have your box plot, and then you can change if you don't want to have the title, then delete the title, and then add the x-axis. Okay, the x-axis is referring to the what we call the correction time. Okay, so the correction time, put the correction time. Okay, done with the box plot. So you can see. So from the box plot also you can see that the data concentration is merely in this particular region. Okay, so that's how we can use a scatter plot to come out with our dots plot. Now let us move to our calculation of our mean, mode, and median. Okay, how can we use the Excel to come up with the tree of measure of central tendency? Now, if you look here, okay, I'm calculating the mode. Okay, so how you can create a click equal sign and then mode. So choose mode for multiple. Double click and then highlight the value and then close the bracket and then enter. So it will give you the mode value. What about the median? Same, use equal to and then median. And then it will automatically calculate for you 15.5. Okay, so remember, in order to get the median, it will be the data need to be sort from lowest to highest value, then only you can find the median. And for the average, you can use the average function equal to average. Okay, so double click average and then enter. You get 16. Now you have got your mean, mode, and median. Okay, finish with the measure of central tendency for the ungrouped data. So class, if we go back to our data just now, okay, and if you look at your textbook on page 20, look on page 20. Okay, on page 20, please look at your table 1.15. Okay, shape of distribution. Okay, are you all with me, class? Are you all with me,
Yes, madam.
class?
Yes, madam.
Okay, okay, thank you. Just to make sure that you are with me, since this is an online class, I cannot see you. Okay, so now, class, remember back when we talking about measure of central tendency, we are talking about the mean, mode, and median. Okay, so the location of this particular three measure will determine the way your distribution of your data looks like. So if you look at your data, if you look at your table 1.15, okay, class, I'm sorry because I did not snap the picture of that particular table 1.15. If you can see from that, actually relate to that particular table 1.15 with this particular figure. Okay, so let us begin with the middle value, the middle figure. Okay, when you have the value of the mean, the value of the median, and the value of the mode, okay, they share the same value. Okay, the same goes to your, actually in your table 1.15, the middle figure, this is what we call symmetric distribution. Symmetric distribution, or in statistic they call it as normal distribution. Means that all the mean, mode, and median share the same value. So mean, mode, median equal to one value only. Now, if your value of your mean is smaller than the median and the median is smaller than the mode, then we call it as left skewed distribution. So this concept we like to ask in your questions, be it in your quiz and in your midterm exam. Okay, so please understand this concept carefully. Okay, so means that your data will more skewed to the left. That's why we call it left skewed. Okay, and if your data, the mode is smaller, see, this one is the mode, is smaller than the median, and the median is smaller than the mean. Okay, when you have this particular situation, we know that it is skewed to the right, then we call it as right skewed distribution. Okay, so later we will see how this particular box plot can tell us more about this particular measure of central tendency. Okay, so class, if you look at your measure of central tendency, look at page 22. Page 22, sorry. Page 22, in table 1.16. Table 1.16. Now class, in that particular table, we have summarized this. Okay, summary of which of the best measure for measure of central tendency. Okay, it depends. Okay, it depends. Okay, so if you look at table 1.16, most common or frequent data in a data set. So types of data: qualitative, quantitative, nominal, and ordinal. So means that if your data is nominal, okay, is nominal, most of the time we will use the mode to describe the measure of central tendency, but depends on the data. So you have to look at the data first, plot them, then only you can conclude this. But basically, this is how we can conclude. But in your textbook, the mode, the data types can be nominal, ordinal, or quantitative. So ordinal or quantitative. Okay, so you can use the mode. If the median, okay, the median, you can use ordinal or quantitative. Okay, the best measure is the median. Now for the mean, okay, the mean, okay, if you have not skewed mean this is not skewed, then the mean will be the best to use. Okay, so here the mean will be used in order to describe our measure of central tendency. If your data skewed, then remember, since the median is located in the median, so that's why we use median as our measure of central tendency. Okay, class, that's how we decide on which measure of central tendency that we will use to represent our data. Can we use 3 of them at the same time? No. We can only use one of them. So the way we choose goes back to the condition that we have here and here. Okay, class? Are you all okay? Okay, so we finish with the measure of central tendency. Okay, so next we are going to see measure of dispersion. Okay, measure of dispersion. Now, what is the difference between measure of central tendency and measure of dispersion? Okay, class. For your information, I'm not going to share with you the video. So I just want you to just focus on the during the class. The video I just to save, and maybe I would like to use it later. Okay, so please make sure that you understand the lecture. Now, last time when we are talking about measure of central tendency, if let's say we have our data, okay, if we plot using the dot plots, for example, okay, we have the dots plot for our data. Okay, so looking at our data, we might have what we call here, it will be your X bar. Okay, here could be the median as well. Okay, the median can be also here. But the mode, the mode is also here, X. Okay, because basically it is the highest frequency, so this is the mode. For example, let's say this is the case where we have this particular data. So measure of central tendency means that we are talking about the middle value. Now, why does measure of central tendency is insufficient? Can we just use measure of central tendency to talk about to know more about our data? Yes, we can use our measure of central tendency. For example, if I enter your class, you have, for example, maybe 20 students. Okay, before I go to the class, maybe the class representative, last time the class representative Firdaus, if I'm not mistaken, Firdaus come and see me before I went to the class. So I asked Firdaus, okay Firdaus, how many students in your class? 20. Okay, fine. Can you tell me about the average height of your friends in your class? Then Firdaus said, okay, madam, the average height of my friends in my class is, for example, if I'm talking about the height, let's say Firdaus said the mean of height is 170, for example, centimeter. Okay, fine. Thank you, Firdaus, I said. Then I went to the class. When I went to the class, okay, I enter the class and I see there are few girls inside the class. Okay, there are few girls inside the class. So when I see the girls, I can say that the height of the girl, okay, maybe 157 cm. Then I will say to Firdaus, how come you say the height, average height is 170? But when I see your friends, your female friends, their height is 157. Okay, 157. So, class, in this particular case, this is where the measure of central tendency is not enough to describe your data. Can someone repeat my last word? Why measure of central tendency is not enough to describe our data? Someone, please. Class, come. Why measure of central tendency is not enough to describe the data that we have? Someone, please. Yeah, the answer is here. The answer is here. Why measure of central tendency is not enough to describe our data? Tak boleh bahasa Inggeris, bahasa Melayu. Cakap Melayu. Someone, please. Class, are you all with me now? Ke saya cakap seorang-seorang ni? Ada 19 orang, 18 orang kat sini ni. Someone please. Try. Salah pun tak apa. Sebab apa saya tak boleh nak bergantung kepada measure of central tendency sahaja untuk describe saya punya data? Why I cannot depend only on the measure of central tendency to describe my data?
Because kawan perempuan dia ni tinggi dia 157 je. Dia tak sampai 170. Jadi tak boleh nak buat ni.
Because, okay, thank you for your answer. When we are looking at the central value, okay, we are talking about one value that is represented in the middle. Okay, but when we have our data, we know that our data will be distributed from the minimum value to the maximum value here. There will be chances that the middle data may not capture the whole information of our data. So that's why we need to have the measure of dispersion. How? Because we are going to measure the dispersion of our data, how our data is being spread from the middle to the minimum value and to the maximum value. Okay, so that's why we cannot depend only in using the measure of central tendency, because measure of central tendency cannot describe the whole story about the data. So that's why we add another measure that will be measure of dispersion. Okay, how the data spread. Is it spread too much or is it spread very small? Okay, so how do we measure this dispersion? Okay, the first one is range, the second one is variance, the third one is standard deviation. Okay, so this is how we measure the dispersion. The easiest one is the range. Okay, how we measure the range? We are taking the largest value minus the smallest value. Means that if we have largest is 13, smallest is 1, so we deduct 13 with 1, so we have 12. So in this case, we know that the spread from the minimum value to the maximum value is 12. Okay, so that will be the first measure of dispersion using range. Okay, now let us look again. If I take the if you look at your example on the example on page 28 in the book, page 28. Okay, it shows you the Excel part. Okay, so the Excel part. Now you have the external ring here. Okay, so you have all the measure for the external ring here, and then you wish to know what is the range. Okay, what is the range? So you let's say we use the dots plot. Okay, so when we plot the dots plot, we have this particular plot. Okay, so the range will be the maximum value minus the minimum value, so you have 0.2. Since this is very small differences, so that's why from this part to this part the dispersion is 0.2. You can say that the dispersion is very small because the differences between the data also very small. Okay, so the next one is how range can be misleading. Means that range sometimes may not be suitable to be used to describe the dispersion of our data, the spread of our data. Let us look at these two examples. Okay, so now example, if you see this particular, the first example here. Okay, so if you have this particular data, each value appear only once. 7, 1, 8, 1, 9, 1, 10, 1, 11, 1, 12, 1. The same data, okay, still have minimum value 7 but maximum 12. But look at the way the dots plot looks like. So you know that 12 is much larger here. So if you plot in terms of the value, okay, you can see the range is still 5. Here also is still 5. But you can see that the data may not be telling you the truth. So if you look at this particular second example, if you have outliers, the first one, repetition or frequency of the data will reflect that the range may not be good to be used. The second one, if you got outliers. For example, okay, the first data, 1, 2, 3, 4, 5. Okay, the second one is 1, 2, 3, 4, 120. See, the range will be, the maximum is 5, the minimum is 1, the range is 4. The minimum here is 1, then the maximum is 120, then the range is 119. But look at the data. Okay, look at the data. So, range cannot be used because the outlier can affect the distribution of the data. Okay, so it will be misleading. So, whenever there is an outlier, range will no longer suitable to be used. Or when there are frequency, greater frequency for certain value, then range also cannot be used. So that will be for range. Okay, how does range tells you about the dispersion? What about the variance? Okay, now the variance is a measure of dispersion of values based on their deviation from the mean. Okay, and the variance is defined as this one. Now, let me use this particular example. Okay, external ring here. What is the variance? Is the measure of dispersion of values based on the deviation from the mean. Deviation from the mean. So, if you look at the formula, so if you are talking about your sample, then this is how you use the formula. If you're talking about the population, then the notation would be different. Okay, so how does this reflect your variance? Okay, class. See what happened here? You have x minus x bar. So we know that the x bar here is 3.001. Okay, so 3.001 somewhere here. Okay, now deviation from the mean. So if you are talking about your data 2.99, deviate from the mean. So from here to here, so this will be the deviation. From here to here, this will be the deviation. From here to here, from here to here. So all this will be measured from the center value. So that's why in this case we have this particular formula is applied. Okay, so we have variance will be s squared. So the way we calculate will be 2.9 minus 3.001 squared plus second value 2.92. 2.92 minus 3.001 squared plus until the last value you will get here 3.10. 3.10 minus 3.001 squared. And all this will be divided by n minus 1. Okay, so that's why we measure. Remember class, when in this part we will get negative value. Here negative value. So in this part all the value is negative. From this part to this part all value are positive value. Since we have negative and positive, that's why we square them, so that the negative value won't affect the calculation. Okay, so that's how we calculate the dispersion for variance. And in fact, from previous up until now, variance is the mostly used measure of dispersion for data. So until now, variance is very important. So if you are talking about the dispersion, sometimes people will ask you, what is the variance for your data? What is the standard deviation for your data? So if you are talking about standard deviation, so in this case, let's say S squared is 0.002, then this is the variance. And what is your standard deviation? Your standard deviation will be square root of the variance. So this will be your standard deviation. So standard deviation and variance is the most important value in statistics. Most of the time, you are talking about variance and standard deviation in your analysis. Okay. So far, do you have any question, class? Any questions so far, class? Any question?
No, madam.
Okay. Now, before we move to our the last one is measure of position. Okay, so let us look what does measure of dispersion which reflect the variance and standard deviation tells you. Imagine you have this data. Let's talk about this, the first data. Okay, now you have the smallest value is I believe is 3, and the highest value is 50. Okay, from the calculation we know that the mean is 27.5, so this is the MCT. Okay, now when you calculate your variance, okay, your variance will be 206.25. This will be the first value that describe the dispersion of your data. Means that if you can imagine, oh, the variance, which means the deviation from each data to the center value, which is the mean, is equal to 206.25. Fine. Now, what is the most important? The most important thing is your standard deviation. Square root of the variance, you will get the standard deviation of your data. Now, where does your standard deviation located? So in this case, your standard deviation is 14.36. Okay, 14.36 somewhere located over here means that most of your data will be below the average value. Means that the dispersion is very small. Okay, very small. Now, let's look at the second figure. Data set with smaller variance is closely spread. Okay, data with higher variance is widely spread. High variance, widely spread. Okay, data set with smaller variance, closely spread. So let us look here. Your data, for example, here and all the dots here. And then your mean is 27. So 27 is over here. And then your variance is 26 and your standard deviation is 5.16. So somewhere over here is the standard deviation. See, class, the dispersion from the center point, okay, is very small. Okay, is very small. Any questions so far, class? See the variance. The variance is your first what we call indication to show you how big is your spread. Okay. Any questions so far? If no, let us look at the third figure. Now you have two what we call distribution, symmetric distribution or normal distribution. One with larger standard deviation and second with smaller standard deviation. Now class, which of the deviation is good? Smaller standard deviation or larger standard deviation, class? Can someone answer? Class, smaller standard deviation is better or larger standard deviation is better? Class? Are you all what was that? Larger or smaller? But better.
Smaller variation. Smaller.
Yes, smaller standard deviation reflects smaller variance. Larger standard deviation reflect larger variance. This one, smaller variance. Okay, so remember back last time when we discussed about variability. You have group A, group B, group C who measure the skewers. Last time we say C is much better in terms of the skewer value. Okay, length of skewer. Now B. So C, you have, for example, like this one. Very close. Okay, so you can see that these two higher variability, but this one, most of them are close together. So here we can say that this one is lower variability. Lower variability will reflect lower variance. Lower variance means that you have the distribution of this part. Okay, so if you are working later on in your company, the lower the variance is better for your company because you are talking about small differences in your output as compared to larger variation. So class, so please remember and understand which kind of data with smaller or higher value is better in terms of representing your data. Okay, now the last part, okay, about data dispersion is your empirical rule. So empirical rule you can see on page 29. So please make sure you understand this particular empirical rule. So empirical rule is very important in terms of standardizing the way the dispersion of your data. Okay, how? So let us look at this particular figure. Okay, measure of dispersion, empirical rule for data dispersion. Now, what does this empirical rule tells you? Empirical rule. What does it tell you? Okay, class. If you are talking about empirical rule, first you need to remember you are talking about symmetric distribution. Means that your data is normal. Okay, symmetric means that the left hand side is the same as the right hand side. The length is the same. Okay, so that's why we call it empirical rule, because first is symmetric. Second, it tells you where does the observation lies. How many observation lies within the standard deviation. Okay, so how? Let us look. Look at the middle. Here is the mean. Okay, we know that we are talking about X bar, which reflect the mean population. We are talking about standard deviation or variance or standard deviation. Okay, for our population is sigma. So this is sample, this is population. Okay, so this is mean, this is standard deviation. Okay, now we are talking about values from the middle where the X bar located. Now, this is your X bar. If I want to say about one standard deviation away, remember just now when I talk about standard deviation, how much it deviate from the center value to the standard deviation here. The same goes here. How much does the value of the standard deviation go away from the middle value? So here we repeat again. By using one standard deviation. For example, let's say X bar is equal to 25. So here is 25. Sigma or S is equal to, for example, maybe let's say I put it as 1.5. Okay, 1.5. In this case, you have X bar and sigma means that you are talking about standard deviation for the population. Okay, but the calculation is using the X bar, so you don't have to worry about that. Okay, so if you are talking about one standard deviation, means that X bar plus minus 1S. Okay, ataupun dalam kes ini kita guna yang population to make it clear, so it will be 1 sigma. So this is called what? So you have 25 plus minus 1 multiplied with 1.5. So let's say this is your sigma. Okay, so you will get 25 plus minus 1.5. Okay, so you will have what? 23.5 betul ke? So ini dapat 26.5 and lower value would be 23.5. So you are talking about first is 23.5 until here is 26.5. That is one standard deviation. If you are talking about two standard deviation, X bar plus 2 sigma, then it will be wider. 25 plus minus 2 multiplied with 1.5, you will get 25 plus minus 3. Right? So then you will have 25 minus 20 minus 3, you will get here is 22, and here you will get 28.5. Now, what happened and what do we mean by this one standard deviation, two standard deviation, three standard deviation? Class, if you are talking about your data within one standard deviation, means that, okay, approximately 68% of your data will be within one standard deviation. If let's say your n is equal to 100. Okay, means that 68 of your data will be located in the middle. Okay, so the rest of your 32 data, So means that your 32 data, so where does your 32 data? It could be over here or it could be in this area. Class, can I ask you, do you understand this? Empirical rule is very important. You have to know. So if you're being asked, you need to understand how you can use the empirical rule. So means that if you are talking about 100 data, 68% means that 68 data will be inside this particular region, and the other 32 data is either located over here or over here, somewhere over here, from here to here. So this is where 32 data can be located. Okay, clear class? Class understand? Understand?
Clear.
Okay, now if let's say you are talking two standard deviation. Now, if for two standard deviation, let me change the pen. So for two standard deviation, okay, saya guna warna biru. Now, you will have 95% of your data will be located from here to here. Means that from here to here, you will have 95 of your data inside the region. So what about the 5 data? Your 5 data can be either at this tail or at this tail. Okay, either here or here. Okay, so the larger the standard deviation, the more data will be included in your data set in the region of that particular 1 standard deviation, 2 standard deviation. So if you are talking about 3 standard deviation, most of your data will be inside the region. So means that the last part here, let me put orange color. So this is where the region for 5% data. Okay, 5% data, 5. So the 5 is either here or, 1. 5 is for 95%. So you are talking about 1 data. So 1 could be is either here or is here. So empirical rule, you will see this again in chapter 2. Okay, so empirical rule, statistician will always use empirical rules in their calculation that reflect standard deviation and dispersion. So this one is being simplified using this figure. Okay, if you are talking about 1 standard deviation, so here is 1 standard deviation. So here is 2 standard deviation. So from here until here, you are talking about 3 standard deviation. From the middle, okay? From the middle. Okay? So that will be, so let us look last question, last example before we end our class. Okay, so let us look again at our external ring here. Okay, so if you look at this particular external ring here, if you later you use again what is your x bar, what is your standard deviation, then calculate for 1 standard deviation, that will be x bar plus minus 1s. 2 standard deviation, x bar plus 2s. 3 standard deviation, x bar plus minus 3 standard deviation. So if you plot them, okay, let's say you're talking about 68% means that you are talking about 20, right? 20 data set. 20 data. So from 20, can someone please calculate 68% of 20, how many? 68% multiply with 20. How many you get? Can someone please? Calculate. Class, are you all with me?
Ada.
Okay. 0.68 multiply with 20. What is the value?
13.6.
13.6. Take it as 14. What about 95%? So 0.95. Listen. 0.95 multiply with 20. How many?
19.
19. Okay, 0.997 multiply with 20.
19.94. 94. 19.94.
19.94 means that 20. Okay, so that means that for 68%, so there will be 14 data inside. If you're talking about 95% here from here, so you will have 19 data included. So means that for 14 just now, 14, so 6 data can be in this region or can be in this region. 6 can be 3 over here, can be 3 over here, we don't know, but you have to check. Okay, if you're talking about 90 and 99.7%, it seems that all the data is included inside. All inside, no data outside the region. Okay, so for 19, your data can be either, so for 19, x bar, x bar plus 2 standard deviation, x bar, sorry, this is minus plus 2 standard deviation, so this one is minus, x bar minus 2 standard deviation. So you will have 19 data inside. Your one data could be over here or could be over here. One data, we don't know. Okay, so that's how we can use empirical rules in order to understand our data. So I think that's all for today's class. I will give the link for the attendance in your Telegram afterwards.